What's going to happen if we eventually meet space aliens, and specifically alien scientists? If these aliens could see electrons or smell photons, would their science look anything like ours? Is physics a universal language or just a local dialect of the human brain? Would alien scientists even use math and equations, or might their truths be organized in a way that we just don't recognize? Are the laws of nature really laws, or simply the stories that our species tells about its slice of reality? Could alien technology emerge from entirely different questions, things that we find boring or irrelevant or literally invisible? What would it mean if science itself is not universal, but just another product of evolution? Today, we'll speak with physicist Daniel Whiteson, who's just written a new book called Do Aliens Speak Physics? So get ready for a terrific brain stretch. Welcome to Inner Cosmos with me, David Eagleman. I'm a neuroscientist and author at Stanford. And in these episodes, we sail deeply into our 3-pound universe to understand how we see the world, and sometimes how different creatures might see the world very differently. So let's start here. When we imagine extraterrestrial life, we usually picture aliens through the only template that we know, which is a mashup of Earth creatures, including aliens we've seen in movies and television. We see animals stretched and tinted into something just foreign enough to qualify as aliens. They might have big eyes and green skin and maybe tentacles or extra limbs, but quite possibly, when we do find alien life, we're going to find that it looks much, much different than what we have pictured so far. Now, I just want to bring that up as a table setting for today's much deeper question, not about what aliens might look like, it's about how they might think. Here's why this matters. Every creature on our planet already lives within its own private universe, a unique Umwelt, or sensory world. My dog, for example, navigates our neighborhood through a riot of smells. So to me, the fire hydrant is just a short metal post, but to him, it's a tapestry of stories that are woven from the animals that passed by. And when I'm away from home and I pop in on a video call, my family is happy to see me, but my dog quickly loses interest. He hears my voice, but it doesn't smell like I'm there. And so to his brain, I'm not really there. And our human Umwelt is shockingly limited. If you're interested in this, check out a talk I gave at TED some years ago. We humans are tuned into a tiny sliver of the electromagnetic spectrum, like 1/10,000,000th of it. So we are blind to most of the light that makes up the world. And for that matter, we are deaf to most sound frequencies out there. And we have absolutely zero perception of lots of things around us, like neutrinos or dark matter. We stitch together our reality from a surprisingly thin trickle of signals, and then we build our sciences on top of that scaffolding. Which raises the question, if our physics is built on our senses in some way, then what would science look like to a creature with utterly different senses? Imagine aliens who can see electrons or smell photons or feel dark matter the way that we see and smell and taste an apple. Would they arrive at the same equations we do? Would they describe the universe with particles and forces? Or would those concepts feel to them something like Roman numerals, which we'll talk about in a bit? Now, the reason this is worth asking is because many physicists assume that uncovering the rules of nature is a universal project, one that any intelligent species anywhere in the galaxy would naturally embark on. But what if that's not true? and that the physics we uncover is going to be very specific, not only to our culture, but also to our cognition and our biology. What if physics is less like a mirror of the universe and more like a lens, like a little narrow straw we're looking through? These questions cut to the heart of what science is. Is it a singular convergent path towards truth, or is it a story where different observers, bound by their unique sensory limits, tell very different tales about reality? That's the territory we get to explore today with my guest, physicist and author Daniel Whiteson. These are exactly the questions that he has been asking. If and when we meet aliens, will their breakthroughs unlock mysteries that we still fumble with? Or will their science maybe be something we wouldn't even recognize as science? Daniel Whiteson is a particle physicist at UC Irvine, and he's the co-host of the podcast Daniel and Kelly's Extraordinary Universe. He's also the co-author of several books exploring the big questions at the edge of physics. His latest book, which comes out this week, is called Do Aliens Speak Physics? And it dives straight into this puzzle: what aliens might know that we don't know, and how their science might diverge from ours in ways we haven't considered. So let's dive in. Okay, so Daniel, when sociologists look across cultures, they find various things where they say, look, this is culturally arbitrary. This just happens to come from the history of this particular culture. Now, the question you're asking is, when we discover alien life, will we realize that something about our math and physics is, let's say, culturally arbitrary, or is there something fundamental about that? So let's dive into that.
Yeah, I think it's a really important question we haven't spent enough time thinking about, but like lots of questions about aliens, either answer is amazing. Like either the aliens are doing physics the way that we are, which means that we're like uncovering the truth. We're like revealing the nature of the universe itself, which makes our physics incredibly powerful and relevant across the galaxy. Or aliens are doing physics in a very different way than we are. Maybe they're perceiving a different slice of the universe, or they're asking different questions, or they have found different answers, or they just take a different approach because of their path through exploring the universe. In that case, we have an opportunity to learn something really fascinating about the lens of the human experience, how our humanity has colored the physics, the explanations that we've developed about our experience. So either way, when we discover aliens and get to try to talk physics with them, we're going to learn something fantastic.
And so the way that you go about this in your fantastic new book is you say, look, this is the Drake equation, and I'm going to propose sort of an extension of it. So let's remind our listeners what the Drake equation is first, and then tell us about your extension.
Yeah, so the Drake equation is a way to try to estimate how many aliens are out there that we could communicate with. And this seems like a really overwhelming question. And so the beauty of the Drake equation, though it's so simple, it's just a bunch of numbers multiplied together, is that it expresses it in parts. It says, well, let's just start by asking how many stars are there out there in the galaxy? And that turns out to be a huge number. We now know hundreds of billions, which is a great start. But then it asks, well, what fraction of those stars have planets where life might evolve? And then what fraction of those planets might have life? And what fraction of that life might be intelligent? What fraction of those intelligent civilizations might develop technology that could communicate with us? And what fraction of those exist in the right time period to talk to us? So the structure of the Drake equation, multiplying all these terms together, emphasizes something really important, which is for this to work, for there to be aliens out there in the universe that are similar enough for us to talk to them, everything has to fall into place. You need the star, you need the planet, you need life, you need intelligence, you need civilization, you need technology, and you need the time. If any of those numbers are zero, then you got no aliens. Like people often say, look, of course there are aliens out there. Look at the number of planets. There's a huge number of planets out there. Yeah, but if the fraction of those that have life is 1 over 10 to the 50, then we're alone in the galaxy, despite the huge number of stars and planets. So that's the concept behind the Drake equation. But the structure of it really emphasizes how you need all of these pieces to come together in order to have that contact with aliens.
Now, what you proposed is an extension to that. Tell us about that.
Yeah. So I'm not just satisfied with there being aliens out there. I want to talk to aliens about physics. I want to know, are they on the same path as we are, but maybe like 1,000, a million, a billion years ahead of us? Like, we have been banging our heads on the question of quantum gravity for 100 years. How do we reconcile Einstein's theory of relativity with our knowledge that the universe is fundamentally uncertain? These two things just don't fit together. And we've been trying and struggling. And there's many deep questions in physics that we could answer, but what if the aliens just know the answers? What if they have this figured out? They have answers to questions we haven't even imagined yet. That would be so fantastic. So in this book, I imagine, or I try to estimate what fraction of aliens out there could talk to us about physics. And in order for that to happen, a lot of things have to fall into place. And that's sort of the structure of the book. Number one, they have to be interested in these questions, have to be doing science in the first place. Like, how do we know that aliens wonder why? And like lots of the questions in the book, your initial reaction is, well, of course they do, or, they have to. But that's exactly the intuition I want to dig into, because often we're biased as humans. We tend to think that our example, the way we do things, the place we live, our location in the universe is important or central or fundamental. And the history of science has taught us, or history of philosophy has taught us, that unpacking those skepticism is very valuable.
So, for example, kangaroos don't particularly care about any questions that we have here. Or you can imagine space aliens that care about a very different set of questions than we do. What would be an example of that?
Yeah, so the kind of things that we're excited about are like, hey, how do planets form? What are the conditions under which planets form, and how long do they survive, et cetera? Why? Because we evolved on a planet. And so we tend to think planets are really important. But planets are sort of an arbitrary made up thing. And the whole argument in the last 10 years about what is a planet, is Pluto a planet, how do you define a planet, really reveals that. I mean, planets are tiny little dots around stars. Think about the way that we depict the solar system. Typically we have the sun, we have all the planets, and they're roughly the same size, which means that we've taken the planets and blown them up, right? Way beyond their real size, because they're important to us.
Whereas the sun is actually 1 million times larger than the Earth.
Yeah. The solar system is basically the sun plus a couple little details, right? Sun, Jupiter, ... But in our depictions, we blow up the planets. And, the definition of a planet isn't even something that people agree on. Our astronomers are still arguing about it. And the reason is that it's important to us. It's not fundamentally important to the universe. The solar system turns out to be, mostly the sun plus a bunch of rocks of different sizes and shapes. And we have drawn arbitrary dotted lines around this concept of a planet because we grew up on one. So we think it's important. What if aliens evolved in the atmospheres of stars? And they're like, planets, who cares? Or, around in an ocean on a moon. And they're like, yeah, planets, are not the most important thing. I think the experience of our humanity leads us to think that certain things are fundamental and important, and aliens might come at it from a different way and ask different questions. And so that's another element of this extended Drake equation. First, I ask, do aliens do science at all? Because if not, what can we talk to them about if they don't even care? And then I ask, could we actually make a mental contact with them? Could we establish communication? Could we learn to translate these concepts in our minds into alien brains and back and forth? And then, as you say, do they ask the same questions? Are they interested in the same things? Do they perceive the same parts of the universe even? And then finally, the answers, the juicy thing. I ask in the book, could we understand alien answers? Or is it possible aliens have an alternative theory of physics that works just as well as ours, but tells a very, very different story about what's happening in the universe? So because this question of do aliens do physics like we do is too big and overwhelming, I extended the Drake equation, used the same structure to ask in turn, do they do science? Can we communicate with them? Do they have the same questions? And do they have the same answers? Those are the other terms in the extended Drake equation.
So let's start with this issue about, would aliens use math and physics, the kind of tools that we use, or might they use something else entirely?
Yeah, This is something that's often cited as a great way to start talking to aliens, is to begin with mathematics, because mathematics is so basic to our science, and some people think it must be fundamental to the universe. And there's lots of good arguments that math is part of the universe. We, as human physicists, have found many times that math leads us to the truth, like the pure mathematics of it. There's an example of group theory. This is a concept in abstract algebra that math nerds played around with, hundreds of years ago, just because they thought it was cool. They're like, look at these patterns. You can play these games. This is super awesome. They didn't care if it was relevant. 100 years after they figured it out, physicists were like, ooh, actually, it turns out this perfectly describes the interactions of fundamental particles and shows us patterns we hadn't imagined, and it just clicks into place beautifully. So the math was there before the physics, right? And it suggests that the math reflects the nature of reality itself, right? That it's not our description of reality, but it's somehow revealing the source code itself. And of course, that's what we want it to be true. We want, as physicists, we're hoping to unravel the nature of reality, not just tell a story about it. We want to be describing the territory, not just a random map of the territory. So there are lots of great arguments that math could be fundamental, that math might be part of the universe. But because it's philosophy, of course, there are great arguments on the other side also. And there are strong hints that suggest that maybe math is a human way of thinking and a way to express human ideas compactly, that maybe it's very, very useful for doing physics, but maybe it's not absolutely necessary, and aliens could have a different approach.
And in fact, if they see the world very differently, not picking up on our little tiny window of electromagnetic radiation, maybe not picking up on air compression waves the way that we do, but living in a really different sort of Umwelt, this notion of what signals you pick up from the environment, the question is, would they have an extraordinarily different way of picking up on information and expressing it other than math and physics?
Exactly. And this is something you must know a lot about as a neuroscientist, but our experience of the world doesn't perfectly mirror the actual reality out there, right? We have these narrow little conduits from which we get information about the world, sight, sense, touch, etc. And they create in our minds this sense of what the world is, but we also know, obviously, that it's incomplete. Right? Like, we see certain wavelengths of light, but there's light everywhere that's invisible to us. We know that there are particles flowing through us all the time. Neutrinos are everywhere, and they're not rare. There's like billions of neutrinos passing through your fingernails every second. If you could see neutrinos, it'd be all you could see, right? There's dark matter out there. There's all sorts of crazy stuff that we cannot sense or interact with. So our slice of the universe that we perceive is desperately incomplete, which means that our sensorium, the idea we have about where we are in the universe, is something sort of concocted to allow us to survive. And, evolutionary biologists and neuroscientists know much more about that than I do. But what we know is that it's incomplete. And that suggests that aliens, who might evolve in different circumstances and have different needs, could develop a different set of senses. And even here on Earth, we see a vast diversity of senses among the animals.
That's exactly right. And in fact, in 1911, this Baltic physiologist suggested this idea of the Umwelt, which is, as I mentioned, this idea of what are the signals that you're picking up on from around you. So, for example, in the world of the tick, it's just picking up on temperature and butyric acid. That's all it picks up on. For the black ghost knifefish, as it's called, it's just picking up on perturbations in electrical fields. For the blind echolocating bat, it's picking up on air compression waves returning to it. And so the question is, would you develop parallel physics if you had a very different Umwelt? And obviously we can point at the creatures on Earth, but let's imagine there are dark matter civilizations that are living in dark matter and living right next to us, but we can't see them and they can't see us. That's your question, is would they be asking the same kind of questions or entirely different ones?
Yeah, it's a great question. Sort of an extension of the famous philosophical question, like, what is it like to be a bat? Now we're asking, what would it be like to be an alien physicist? And it matters because we can extend our sensations technologically, like we develop infrared sensors and we develop sensors that can detect neutrinos, etc. But in the end, we're always translating it back into the language we find intuitive. The job of physics, of human physics at least, is to take the unfamiliar and make it familiar. Think about how we describe photons. Photons are something new and weird and quantum will never fully grasp, but we describe them in terms of intuitive concepts that make sense to us. We say, oh, it's a particle, it's a wave, it's somehow a weird combination of both. The reality is it's neither. It's something new and bizarre. And we're struggling to understand it because we insist on doing this translation back into something that's intuitive for us. And I think that our sensations, our sensorium, the senses we use to interact with the universe, determine what's intuitive to us. When I think about answering the question like, how is the orbit of Saturn affecting this or that? I'm thinking geometrically, I'm thinking visually, I'm thinking spatially, because that's the way my brain works. So now imagine an alien. And maybe these aliens are microscopic, and so they have some sort of quantum senses that are natural and intuitive to them. Maybe they can see photons in superposition without collapsing them. And so to them, what's intuitive, what makes sense, the language they want to translate the universe into could be vastly different. And their explanations might make no sense to us, and ours might be very confusing to them. And so I think the question of perception not just determines what you initially see, but ultimately dominates the language you use to express yourself, what it's like to be a human or an alien physicist in the universe.
So I love that. And what it reminds me of is an idea that I've been writing about lately, which is Umwelt hacking, which is a term I first heard from my friend Eric Weinstein. But the idea of Umwelt hacking is just that we take things that, for example, are very small and we expand them so that we can see them. Or we take, let's say, light that we cannot see, like ultraviolet or infrared, and we translate it into what we can see. So we're constantly taking everything that we're discovering in the universe and translating it to the little window that we can perceive directly. But what you're suggesting is even the step just beyond that, which is, what is intuitive to us? Like what can we even understand? So we take photons and translate them into a little story that makes sense to us.
Or think about like gravitational waves. When they were discovered, they were described as sound waves. Like, we know they're not sound waves. There's no compression waves, but they're called chirps, and they were translated into literal little sounds that you could play. You could press a button on the internet and hear the gravitational wave, right? Yeah. And people talk about it as if the universe is speaking to us now. And like, that's not what gravitational waves are. But of course, it makes sense to translate them into sound waves so that we can sort of digest them. We do this all the time. We take the pictures from the James Webb Space Telescope, and they don't put them on your computer screen in the IR because they would just look black. They shift them into the visual, and a lot of people might not be aware that they're seeing, color-altered versions of those pictures. So we do this Umwelt hacking all the time, but we're always translating it, right? And so imagine we meet aliens and they have a different Umwelt, and so, for them, these explanations could be very different. Or it would be incredible to be able to be released from that, to just be able to experience the universe in its natural form and not have to always translate it back into the things that, these hairy apes find intuitive.
And you think, and I think, that might actually be impossible. And in chapter 6 of your book, you suggest that maybe instead of revealing a fundamental truth, physics will turn out to be like the film Rashomon. So for any listeners who don't know that film, tell us about the film Rashomon and then tell us why physics might turn out that way.
Yeah, Rashomon is a great film, a classic one, where, some sequence of events happens, but several people tell a different story about it. And so they don't have to disagree on the facts, but they can disagree about why things happen and what it means. And that's important to remember when we're doing physics, because in physics, what we're doing is filling in the gaps between observations. You have your data, you measure this, you measure that, you measure the other thing, and now you're telling a story about why that happened. For example, you have an electron and you have it between two plates and it accelerates. Now you tell a story about why did the electron accelerate? And the typical story is, there's an electric field created by the plates and that pushes on the electron. Cool. But is the field really there, or is it just part of the story? Nobody's ever observed a field itself. They've only observed the effects of the fields. The fields are the invisible story we tell to explain the data. And we do this all the time in physics. It's unavoidable. And it might be that aliens come and they have, oh, no, they have a different story. Like, it's not fields, it's schmields or something totally different. And there's a huge philosophical debate about whether this is possible. Does the universe have to have a single unique explanation for what's going on? Or is it possible to have two different theories of physics, fundamentally conceptually different, that tell different stories about what's happening invisibly behind the curtain, that both work just as well? And what would that mean about the nature of the universe? Like, if you just started to think about this, your initial reaction is, no, that's bonkers. The universe, there's a reality out there. Things happen for a reason, right? There are laws that must be followed, but that's a philosophical assumption. We don't know that's true. And the beauty of this question about aliens is that it might uncover some basic assumptions about the universe we've been making forever we didn't even realize.
So do you think that there are universal problems that every technological species would have to confront? What's your intuition on that?
Wow, I don't know if we can make any universal statements about any intelligent species. I mean, they might have such different evolutionary experiences and face different challenges. You might be tempted to say, like, well, everybody's got to get off planet, right? And so everybody's got to develop some sort of like technology to get lift. But, that's a challenge that exists on our planet because we've kind of a massive planet. And you could imagine aliens evolving on much smaller moons where it's easier to get off planet, for example. And
but they'd still think of gravity, right? They would still have to conceptualize that in some way.
I think probably, but and it might be even more important. Imagine the dark matter aliens you were talking about. Like, we don't know what kind of interactions dark matter might have with itself. Currently, we imagine it only has gravitational interactions. You can imagine some sort of dark matter alien that's incredibly vast, that only has very weak gravitational interactions with itself. And so evolves very slowly. Its time scales could be like, millennia, millions of years. So I think it's impossible to say that there's anything that aliens have to have in common if you take the broadest possible view of aliens. And that's my preference, because the aliens I want to meet are not the Star Trek aliens, humans with little fuzz on their forehead or pointy ears or whatever. I want to meet the aliens that blow our minds, that make us think, what? I didn't even imagine that was possible. Or that's not something we ever considered, because that's the moment when we learn the most about the nature of life in the universe and intelligent life and the experience of being human.
Exactly. And by the way, this is what happens in biology all the time, is we find creatures and we think, wait, what? How does that thing exist? And that expands our internal model of what we think is possible. So I agree with you that when people think about space aliens, we typically think about creatures like, the Star Trek, some woman in a tight jumpsuit or something living on a different planet. But of course, they don't have to be from planets at all. They could be really giant things that span galaxies and live in the dark matter part, and they have a totally different set of issues.
But in order for us to connect with them, right, we have to have something in common. And that's why, the book is structured in this way. Like, it's possible that there's lots of aliens out there that we have nothing in common with, that, we have coffee with them, and we're like, yeah, that was fun, but we're not interested in chatting again. And the aliens I really want to meet are the ones that ask similar questions to us, that are curious about the universe the way that we are. But there's no guarantee, right? It's possible the universe is teeming with aliens, but we're the only curious ones.
Or that the territory of our curiosity is so different that they don't overlap much. For example, let's imagine that we could do animal uplift so that we could talk to squirrels and chat with them about it. It's not totally clear how much we'd have in common with them. Or if we could do that with bacteria, we would really have very different worlds.
I think even with whales or with chimps, and the challenge of like making those mental connections is underscored by the fact that we haven't. Like, we've been on the planet with whales and dolphins and chimps for a long, long time, and we haven't figured out how to cross that brain-to-brain connection to make that interaction work, which, a lot of people imagine the aliens show up and we're like, ... the linguists figure it out in 10 minutes and then we're at the chalkboard. But like, I think that really undersells the challenge of making that brain-to-brain connection.
By the way, one of the things that I've always been interested in, several podcasts involve this issue, is what if there are alien species that live on a totally different time scale than we do, where we are like the tree people to them or vice versa? What are your thoughts on that?
Yeah, I think that's absolutely possible. There are all these things that we find intuitive and natural, right? And one of them is a sense of time. But the universe operates on incredibly vast timescales. Like there are things that happened over millions and billions of years that we have a hard time processing. Like think about, understanding glaciers. People thought it was ridiculous to imagine that like ice moves slowly over the surface of the earth and scrapes out valleys because it was such a long time-scale process. It was just hard for us to grok or to think about plate tectonics in the same way. But the universe has deep time. And if you look at like the formation of our solar system, we tend to think of the solar system as this like steady thing that rolls around the sun in a natural way. But if you look back into history, like it's quite chaotic. We think maybe there was another planet that got kicked out when Jupiter, entered the inner solar system and then got pulled back out by Saturn. It's crazy chaotic if you think about it on a much faster timescale. And on the other end, there's lots of things that are important in the universe that happen much, much faster timescales than we exist. Quantum mechanics is like blindingly fast. I do experiments at the Large Hadron Collider. We study particles that exist for like 10 to the negative 23 seconds. So there's this incredible range of time for physical processes. And what we find intuitive are things that like take 1 second, 10 seconds, maybe 100 years. So absolutely, I think that a lot of our physics is deeply influenced by the time scale of our lives.
Yeah. Here's a question. When we look back at the ancient Romans and think about them doing math, they were using Roman numerals. And that just makes it really hard. It's sort of parochial and stupid for that. Anyway, when you think about where our own physics is going, let's call it 1,000 years from now, when we look back at the laws and particles and forces that we talk about now, will that seem parochial and outdated like Roman numerals?
Almost certainly. I mean, the progress in science, despite what a lot of people say online, is exponential. We are learning so much about the universe, so much more every 10 years than we knew in the last 100 years, despite some, long-standing open questions. And so I think it's hard to imagine what our science would be like in 1,000 years. It's hard to imagine, think about like taking Newton and bringing him to today and talking to him about the universe. His mind would be blown, right? The kind of things that we're imagining.
He wouldn't even know how to think about like smartphones. Yeah. Wait, you melted down beach sand and you have, 100 billion calculations in a second. And so, yeah.
Exactly.
Yeah.
There's so many things that would be hard for him to grok. But, the human brain is capable of that. It's incredible how if you evolve in that time period, you find those things natural and then you build upon them. And so that's the incredible thing about human science, is that the next generation begins where we left off, finds it natural and develops a fluency in it, and then is able to leapfrog forward. And so it's so difficult to imagine what human science would be like in 1,000 years, and not just the things we know, but I think also the process of science itself, because this is something that has changed. People think about science, the typical cartoon pop-sci story is, the Greeks were thinking about the universe but not doing experiments until the 1500s when Galileo and Francis Bacon came up with the idea of experiments, and boom, modern science took off. And now we sort of figured out how to figure things out. But the true story is much more nuanced than that. The Greeks did experiments. They measured the curvature of the earth using shadows and rods, right? That's an experiment. The development of the process of science was much more gradual than people like to describe, and it's ongoing. We have new ways of doing science now that Galileo never imagined, like in biology, there's in vivo, in vitro, and now there's in silico, right? We have this computational simulation element to science. So I think that in 1,000 years, probably our science will be unrecognizable. And scientists in 1,000 years will look back and be like, man, they were so basic and primitive in the way they were asking questions and finding answers. So that makes me think that probably alien science The very process of science itself could be very different from what we do. I don't think it's even inevitable that they have the same process. They could be down some other path, some other technique for figuring out the nature of the universe we can't even imagine. So even on that level, we could learn a lot.
Yeah. And what that means is that for our descendants 1,000 years from now, they are essentially aliens to us as we are to them.
Exactly. We are our own aliens. I love that.
Yeah. And of course, it turns out that science is changing so rapidly right now just because of AI. I mean, all of us have these massive data sets that we've always put armies of grad students on and plugged through one little thing at a time. Like, things are changing so rapidly now in terms of the in silico being able to do things for us that the whole process, it makes me wonder a lot whether there's going to end up being a massive retirement of scientists, just because a lot of the things that are worth doing a 3 or 5 year project on can be done in 3 or 5 milliseconds now.
Yeah, but I think that just expands the kind of science that we can do.
Agreed.
Science in the end is a human thing. It comes from our curiosity. It's questions we are asking. The AI is not curious about the universe. It just does what we're telling it to do. And, I see in biology exactly that kind of transformation. My wife is a biochemist, and, things that took people a PhD to do, then in a few years become a thing on the lab bench. You press a button and it's done. And that doesn't mean biology is over. It means they have expanded it. They can now think about bigger questions they couldn't even imagine before. And so AI, similarly, is helping us develop science more rapidly and do things more effectively that we couldn't do before. And I think it's allowing us to ask new questions and find new answers. So I'm not worried about the fate of human scientists. I think that as long as we're curious and we're wondering about the nature of the universe and we value cultural institutions, that's the dangerous part, that we'll still be developing answers and we'll still be in charge of asking the questions.
Excellent. Now, okay, so let's get back to alien scientists. So one of the things we see in biology a lot is what's called convergent evolution, where, for example, birds and insects both figured out flight, even though with totally different pathways. Do you expect convergences in science with us and some alien civilization where we stumble on the same thing, even if by different pathways?
Yeah, possibly. And the way we can try to answer that question is to look back into the history of our science and ask, are there developments that were inevitable or not? And surprisingly, what you find when you look back at the history of science is so much of it, so many of the crucial pieces, the moments when we gained understanding, were due to chance. Were due to accidents, like the discovery of radiation and atomic decay was because a guy put some uranium on a photography plate and the rain spoiled his planned experiment. So he just left it over the weekend. And when he came back on Monday, he developed it and discovered radiation accidentally, right? Because it was rainy in Paris. And the frustrating thing about that is that it could have happened 100 years earlier. All the technology was there, just nobody had that lucky accident. So we could be 100 years deeper into our understanding of quantum mechanics. Imagine if quantum mechanics had been developed 100 years earlier, so that when Einstein is a kid, he's now immersed in quantum mechanics. When he's developing his theory of relativity, he already has a quantum brain. Does he still come up with a classical theory of relativity, which is, strongly in confrontation with quantum mechanics? Or does he just come up with quantum gravity in one fell swoop, So it suggests that there's lots of paths through science, that there's lots of happy accidents that determine the way that science happens. Unfortunately on Earth, we no longer have parallel cultures developing science the way we did, a few thousand years ago before we had globe-spanning civilizations. But at one point, the Mayans, the Chinese, the Greeks were all sort of independently investigating how the universe works. And it would be so fascinating if today we could see where those cultures ended up if they hadn't been intermingled. We would know something about the inevitability of math and astronomy and science and physics. What an amazing experiment that would have been.
Oh, is there enough data historically to ask these questions about which things did they converge on and which went off on different paths?
There is, we dig into it in the book a little bit, and we see that lots of these cultures started with, okay, there are patterns in the sky. Let's try to explain those patterns. They seem to be important. Let's use math to explain those patterns. But there is divergence there. Like the Greeks, very geometrical. To them, answers were like, where are things? Build me a map in my mind. The Chinese were more arithmetic or algebraic. They're like wanted patterns in equations on the table. Things they could write down. They weren't building so much a geometric image. And you can see actually in the ancient literature, some Chinese scholars like trying to take a geometric approach and finding it wasn't really working, and then just like retreating and being like, let's go back to our equations. And so there are divergences there. Of course, later we understood there's a fundamental connection between geometry and algebra, of course. But there definitely were a lot of similarities in the initial path, but we don't know. There isn't enough data to know, like, would they have ended up in the same place or not?
What do you think? What's your intuition about physics? Does it have to look like equations? Or if you were a dark matter creature, would physics be expressed some other way?
Yeah, this is a really fun question. It goes back to the earlier conversation we were having about the necessity of math. And I remember feeling when I was learning about quantum mechanics, like, wow, this is the source code of the universe, man. This is not just a description. This is how the universe decides whether an electron goes left or right, when I'm reading about how precise those equations are and the experiments that validate them. But then I read a book by Hartree Field, and it's called Science Without Numbers. And in this book, he tries to demonstrate that you don't need number lines. All you need are like comparisons, like things that are bigger and smaller. You need relationships. But he argues that this idea of numbers, this number line that we've created, it's useful. It's a nice way to hang things, but you don't actually need it to do science. And he goes through this incredible exercise of developing an alternative theory of gravity with no numbers. Right? So science without numbers, right? And he argues that this concept of a gravitational field or any field is an intermediate calculation that we find useful, but doesn't have to reflect reality. And so his version of gravity has none of these numbers in it. And so it's not expressed that way, you were saying, like with the same kinds of equations. And so that's fascinating, and it's ugly. Like, it's not pretty. It's not a nice way. Nobody's going to use it to do science. But it makes the point that our math, while it's very handy, it's very effective, it's very useful, might not be necessary. It's parts of it could just be convenience. So it's fascinating to think about how aliens might do science. And, even our way of expressing science in equations and symbols is fairly new. When Newton is writing Principia, he's not writing equations. He's expressing things linguistically. He writes the force is related to, he's using English, not the same sort of symbols. So, the way that we do science, we imagine it's fundamental, it's universal, but it's really a snapshot of our current culture and kind of a narrow window of time.
So how would we recognize alien science if we saw it? And what we're doing now, of course, is pointing radio telescopes all over and trying to guess what they might be communicating if there were someone out there.
Yeah, that's a great question. And let me preface by saying I love the SETI project, and I want us to be listening for messages from space, and I think we should support it more. I do think philosophically it might be hopeless. I think that if aliens send us a message, we have almost no chance of recognizing that it's a message, and even in the fantastically lucky scenario when we do that, of decoding it. Because any message we get is going to be translated from their ideas into some kind of code, some kind of symbols, a pattern, sequences, something, even like an engraving on a Pioneer plaque that they send us, right? There's an arbitrary step there where you translate ideas into symbols. It happens in every single language. It's the only way to communicate via brains, right? Through this symbolic step. And those symbols, as much as you try to make them universal, will always reflect your culture. So we get an alien message. We could try to decode it, but we have no idea what their symbols mean or what it reflects about their culture or what things they find natural. And the worst part is, how do we know if we got it right? The Rosetta Stone is a great example because at least we have a cheat sheet. We know what we're supposed to be translating into, though it still took us 20 years to crack hieroglyphics with that cheat sheet. Now, aliens, like we have no cultural in common. We have no clues. We have no context. We have no idea what we're translating it into. I think it's a fantasy to imagine that we could ever translate an alien message. And, we have funny messages from space, like the wow signal, right? This bizarre, never repeated signal from space, very brief. What does it mean? We have no idea. Is it anything? Is it just some weird blip? There are some now theories about how it could maybe be possible astrophysically.
Tell the listeners more about the wow signal, what it is.
Yeah, the wow signal is a signal that came, I think it was in 1977 in a radio array. And, they just were listening to the sky and all of a sudden this signal came through, which is basically exactly what you would expect, a signal from a civilization to look like. It has like a nice smooth shape. It rises and then it falls. And it's called the wow signal because the guy who was monitoring it, this is back in the day when you didn't have like fancy screens. It's like the thing it prints out on a printer. That's the way this telescope operates. He saw this thing and he wrote on it, wow, oh my gosh, because that was his like literal reaction to seeing this signal. And that enthusiasm remains, but that's basically all we have. We have no idea what it was, who it was from, if it was from anybody, what it might mean. Is it a intergalactic ping? Is it an attempt to probe our firewall and then send us a virus? Is it, who knows, right? Or is it just some weird burp from a quasar somewhere? And so that's the challenge of decoding these things, is that we have none of the cultural clues. And so in the book, that's why I argue that the only way this could ever work is if the aliens arrive. Because if they're here, then we can do stuff like we can point to an apple and say apple, and we can point to two apples and say two apples, and we can start, because we have a physical context in common when they're here, we can use that as a way to attach meaning to symbols and then build on those symbols.
So let me ask you this. Let's imagine some aliens arrived, and that means that they've got technology that's better than we do because they've crossed the galaxy, they've gotten here. What is the first question you would ask them after we figured out the language part? What would you ask them about their technology or their worldview?
Yeah. Well, first of all, I don't want to be on that visiting party because I'm a wimp and I don't want to risk being eaten for lunch. But, if the linguists have figured it out and made some contact and we're sitting down with the aliens, then yeah, I have questions. I want to know, how did the universe begin? What were its first moments? I want to know, what is the universe made out of? These are the questions that drive my personal scientific career that I desperately want to know the answer to, because I feel like they're so meaningful philosophically. Like if you knew the way the universe began, and if a factual account, then that would tell you a lot about the context of our lives and its meaning and maybe how we should live it. Or if you knew what the fundamental description of the nature of matter and space and energy were, that would tell you something about what this is, this crazy, bizarre, beautiful, bonkers experience that we're all sharing, what it really means. So I want those answers. And if aliens are out there and they have those answers and they're listening right now, please come talk to us, tell us those answers, because we'll figure it out eventually, but it might take us 1,000 years, 1,000,000 years. And boy, I'm not going to be alive that long. So I just kind of want a cheat sheet. So those are the questions I would ask the aliens if they show up.
Oh, great. I certainly hope some aliens are listening to Inner Cosmos. So here's a question. If aliens explained quantum mechanics to you in a way that suddenly made it feel trivial, they just had a totally different framework, would you feel relieved or would you feel disappointed that we just wasted a century on it?
Absolutely relieved. Absolutely. I mean, that's the best case scenario, right? To have the aliens explain to us and for it to make sense. Because my nightmare scenario is the opposite. Aliens come, they understand quantum mechanics, they try to explain it to us, and we're just like, huh? I don't get it. Like, neurologically, how do we know that we're even capable of representing these ideas in our minds? It boggles my mind that, these brains which developed to be able to like stay warm and dry and fed 1,000,000 years ago can think about like 11-dimensional space and, crazy transformations. Why are we capable of all of this? I don't understand it.
It's only because of the Umwelt hacking, in the sense that we're figuring out ways to squeeze that concept into a concept we can understand, but that probably does have its limitations.
it must have limitations, right? It's certainly not true that we can understand anything in the universe. I mean, my dog is smart, but definitely doesn't understand quantum mechanics as well as I do. And there must be some limitations, but, we have these developments now, as you say earlier, we can extend our understanding using AI. And, in my field in particle physics, we're doing this all the time. There's lots of things that require AI in order for them to work. We're not yet at the point where we require AI to understand things. But, one scenario is the aliens come, they try to explain it to us. We're like, huh? But the AI is like, I got this. And, what if the AI can figure it out, but they can't explain it to us? And then the aliens just like, talk to the AI and leave us out of the party. To me, that's the most frustrating potential scenario, that the answers are out there, the aliens want to share them, and we just can't get it. We just cannot do the Umwelt hacking enough to translate it into intuitive concepts in our mind, get that satisfaction that I'm personally looking for.
Right. The best the AI can do is tell us that the answer is 42, but it can't explain it better than that. Yeah.
Exactly. Douglas Adams was ahead of his time, as always.
Okay, a few rapid fire questions. What is the most ridiculous but possible alien invention that you would love to see?
Self-driving toothbrushes. Why do we have to hold these things? They should just drive themselves around our mouths.
Excellent. If you had a guess, what is one thing that humans might teach aliens that would blow their minds?
Oh, wow. I would love if some cute little bit of human mathematics that we developed just for fun turned out to solve one of their physics problems. Like maybe they've been missing it, and this is just like the chocolate that their peanut butter needed, That would be fantastic. Because as you say, if the aliens show up, they're probably more advanced than we would be. So it'd be wonderful if we could contribute one little thing. And I think maybe that's the most likely.
Oh, that's good. Yeah, we hand them a Penrose tile, and they're like, my God,
yes.
That's it. Yeah, okay, good. Good. If you were invited to sit in an alien classroom physics lecture, what would you expect to see around you? Probably not whiteboards. Would they smell their equations? Would they feel dark matter?
I would be most interested in what those kids are asking, maybe even more than the answers, because what aliens find intuitive and what their kids find weird, I think would tell us a lot about how they sense the universe and whether our questions are meaningful, whether our questions are just part of our humanity or whether our questions reflect something deep about the universe.
That was my interview with physicist Daniel Whiteson, and I hope you felt your mind get stretched way beyond the boundaries of Earth. Thinking about alien science, of course, goes beyond aliens. It's a way of holding a mirror to our own assumptions and asking whether the universe is stranger than we yet perceive, or even stranger than we can perceive. So I find myself looping back to one central idea. When we ask whether aliens would build the same kind of science, we're also asking how human is our science? Are our particles and forces, our laws and equations, discoveries of something universal, or inventions that reflect the peculiarities of our senses and the accidents of our history? I'm given a little bit of hope by thinking about convergent evolution here on Earth. Wings evolved in insects and birds and bats because flight was simply too useful a trick not to stumble on again and again. But the details are different in every lineage. You've got feathers here, you've got membranes there. Maybe science works in the same way. Maybe any technological species will discover certain convergences like gravity or energy or chemistry because those are necessary to survive and thrive. But the way they conceptualize those discoveries may be as different as wings are between a moth and a falcon. And the other really important idea here is that of the Umwelt. Just as my dog inhabits a fragrant cacophony of odors that I can't access, alien intelligences might navigate dimensions of reality that are invisible to us. Their science could be sculpted by those senses and by questions that would never even occur to us. where we wrestle with quantum mechanics. Maybe they stroll through that in first grade, and then they had very different questions in the second grade. Where we ask, why does time only move forward? Perhaps their perception of time makes our question seem quaint or meaningless. One of the things I loved about the conversation today was the notion of counterfactuals, or what ifs. Many of you know that exploring what ifs is the thing I love to do most. And if you've read my book of fiction, Sum, S-U-M, you'll know that I wrote 40 mutually exclusive versions about what we're doing here. And each was meant to stretch the imagination in a different direction. None of the stories in my book are meant to be true. The point is to expand the fence lines of what we can think about. So I'm going to read a very short story today from that book that pairs so nicely with today's conversation. This story is called Giantess. The afterlife is all about softness. You find yourself in a great padded compound. Everything appears designed for quietness and comfort. Your feet fall silently on a cushioned floor. The walls are pillowed. Echoes are dampened by foam ceiling tiles. A hard surface is impossible to find. Feathers pad everything. When you enter the grand hall, the first thing you notice is a sizable and princely man. He looks just as you might expect a god to appear, except that he is noticeably skittish and strained with worry around the eyes. He will probably be explaining that he's greatly disturbed by the nuclear arms proliferation on Earth. He says that he often awakens in a cold sweat with the sounds of colossal blasts hammering in his ears. To be clear, he says to you, I am not your god. Instead, you and I are galactic neighbors. I am from a planet associated with the star you call Turzan 4. We are all in the same mess. What mess, you ask? Please don't talk so loudly, he softly admonishes. For a long time, we have been studying our neighbors, you Earthlings and 37 other planets besides. We have developed highly accurate systems of equations to predict the future growth and social directions of your planets. Here, he fixes your eyes. It turns out that you Earthlings are among the least tranquil and content. Our predictions indicate that your weapons of war will grow increasingly loud. Your space exploration programs will produce thousands of noisy vessels that will thunder throughout the heavens with their deafening rocket propulsion. You Earthlings are like your explorer Cortez, standing atop a mountain peak and preparing to perturb every beach at all the lapping fringes of the Pacific. We're in a mess of expansionism, you manage. That's not the mess, he hisses. Allow me to illustrate the larger picture. You and I, our planets, our galaxy, we're part of what you should think of as an immeasurable living mass. You might call it a giantess. But summarizing the concept in a word might give you the illusion that you can have a hint of a notion of her enormity. To give you a sense of scale, you are the size of an atom for her. Your Earth, sprouting with its untold layers of furiously fecund species, your Earth is tantamount to a single protein in the shadowy depths of a single one of her cells. Our Milky Way constitutes a single cell, but a small one. She consists of hundreds of billions of such cells. For millions of years, my people had no notion of her, just as a flatworm is unlikely to discover that the planet is round. A colony of bacteria will never know the walls of the flask. A single cell in your hand will not know it is contributing to a concerto on the piano. But with advancing philosophy and technology, we came to appreciate our situation. Then, a few millennia ago, it was theorized that we might be able to communicate with her. It was proposed we might decipher her structure, deploy signals, influence her behavior in a manner that infinitesimal molecules, hormones, alcohol, narcotics, influence a creature like you. So we organized and educated ourselves. Instead of fretting through the doomed, ignoble cycles of local politics, we dedicated our economy and sciences toward understanding the biochemistry of universal scales. We methodically mapped out the signaling cascades and stellar anatomy of her nervous system, and at last discovered how to transmit a signal to her consciousness. We sent a sharply defined sequence of electromagnetic pulses, which interacted with local magnetospheres, which influenced asteroid orbits, which nudged planets closer and farther from stars, which dictated the fate of life forms, which changed the gases in the atmospheres, which bent the path of light signals, all in complex interacting cascades we had worked out. Our calculations told us that it took a few hundred years for the transmission to arrive at her consciousness. At the time of the arrival, I was sad to be traveling away from the planet while everyone was so excited to see what would happen. His face twitches with painful trickles of reminiscence. But no one would have guessed what happened next. A great sheet of meteors rained down. Incendiary hydrogen clouds crushed in, and those were followed by a multitude of black holes that mercilessly swallowed up the flying chunks and dust and the last light of remembrance. No one survived. In all probability, this was neutral to her. It might have been an immune system response, or she might have been scratching an itch, or sneezing, or getting a biopsy. So we discovered that we can communicate with her, but we cannot communicate meaningfully. We are of insufficient size. What can we say to her? What question could we ask? How could she communicate an answer back to us? Perhaps that was her attempt to answer. What could you ask her to do that would have relevance to your life? And if she told you what was of importance to her, could you understand her answer? Do you think it would have any meaning at all if you displayed one of your Shakespearean plays to a bacterium? Of course not. Meaning varies with spatial scale. So we have concluded that communicating with her is not impossible, but it is pointless. And that is why we are now hunkered down silently on the surface of this noiseless planet, whispering through a slow orbit, trying not to draw attention to ourselves. Again, the point of my book Some was to expand the territory of our thinking, and Daniel's interest in alien science serves the same purpose. It challenges us to wonder what else is possible, and in doing so, it makes us more aware of the narrowness of our own windows onto reality. So what we see is that speculating about aliens reveals something about ourselves. We live inside these internal models of the world constructed by our brains, and those models are necessarily limited. By imagining alien sciences, we stretch those models and remind ourselves that what we take to be universal might be something much smaller, a reflection of our own history, of our own sensory mechanisms, of our own imagination. So Daniel's journey is an excellent way to loosen the grip of our assumptions, to stand outside our own thought patterns, and to ask, how else might reality be described? So as we finish this episode, I'll leave you with this. The next time you look into the night sky and wonder who else might be out there, try shifting the question. Don't just imagine what aliens look like or what gadgets they've invented. Ask yourself instead, what questions are they asking? What mysteries are obvious to them but invisible to us? And vice versa. And what might our science look like if we had evolved their senses, their histories, their ways of being in the world? Because in the end, thinking about aliens is one of the most powerful ways to understand ourselves. Go to eagleman.com/podcast for more information and to find further reading. Join the weekly discussions on my Substack, and check out and subscribe to Inner Cosmos on YouTube for videos of each episode and to leave comments. Until next time, I'm David Eagleman, and this is Inner Cosmos.